Okay, I'm going to talk about 3 theory courses, CS360, CS365, and CS462. CS360 is the basic introduction to theory of computing. And the goal of this course, similar to 365, I'll talk about that one in a second, it's to understand mathematical models of computers. So in a course like programming languages, you see a lot of different ways that people interact with computers in different styles. But what the 360 does is sort of boil all that down to its really basic essence and say, what is it that we can compute? What is it that we can't compute? And what fundamental models are there? So you're going to understand the limits of computation in this course, especially uncomputability, also called unsolvability. What is it that simply cannot be computed no matter how much power you have? Even if you have unlimited time and space, what things cannot be computed in general? And another point of the course is to gain familiarity with these basic models like finite automata, push-down automata, Turing machine, which you see in a lot of different areas of computer science, not just theoretical computer science. And finally, there's a lot of reading and writing proofs in CS360. So the kinds of topics that you see are things like strings or words, languages and operations on them. One of the basic tools is proof by induction. You look at finite automata, you look at regular expressions, you look at non-determinism, which is accepting or non-accepting based on the existence of a path rather than a single path. There might be multiple ones, some of which accept and some of which don't accept. Context-free grammars, ambiguity, push-down automata, which is a model of finite automaton equipped with a stack, Turing machines, and finally unsolvability. So you would decide to take either 360 or 365, not both, because they cover a lot of the same material. It is typically offered all 3 terms, fall, winter, and spring. When I teach it, typically there are 5 assignments worth 30%, a midterm 25%, a final exam worth 45%, but other people might have different breakdowns on how marks are assigned. Lately we've been using this book, or perhaps a later version of it, Hopcroft, Motwani, and Ullman. It's a book that's been around in various forms since the 60s, but it's been revised, and it's a good reference. Okay, so CS365 is kind of like the advanced version of 360. So the goal of CS365 is you're going to cover a lot of the same material, but you do so at a faster rate. And then because you do it at a faster rate, there's time at the end to look at various topics that are not typically covered in 360. So some of the things that are covered in 365 include time complexity classes, so what can be computed, for example, in polynomial time or exponential time. Space complexity, what can be computed in polynomial space, exponential space. Intractability issues, so things like p-space completeness. And other advanced topics depending on who's teaching it, like parallel complexity classes and probabilistic complexity classes. So the 365 is, if you are really enthusiastic about this material, so if you really like doing proofs and solving problems as opposed to like sitting and coding all night, then 365 is the course for you. So that's people with good mathematical skills who, like, for example, do well on the Putnam, this might be the course for you. It's typically a smaller course, more intimate, and sometimes there are really exciting things happening in that course. So prerequisites for this are 240, 241, SE 112 or CS 245, Math 239, 249, and next. So you wouldn't take that with CS 360, and typically this is only offered in the winter, And when I've taught it, there have been 5 assignments worth 40%, a midterm worth 25, and a final exam worth 35. And the textbook that we've been using is Sipser's Introduction to the Theory of Computation. Okay, so the last course that I'll talk about is CS 462-662. This is the Formal Languages and Parsing. And what this is more or less a follow-up to either 360 or 365. So the goal in this course is to look at topics that you saw in either 360 or 365, but look at them in a much more advanced and deeper setting. So you do see some of the same concepts, but you see almost research level, sometimes even research level material. So another goal is to look at interesting and challenging problems and to learn a theoretical basis for modern parsing methods. So some of the things we talk about are two-ways problem. This is a problem on words. It asks, is there an infinite word that avoids occurrences of 2 blocks sitting next to each other that are identical? We look at, again, at regular languages, we look at closure properties, but now we look at more advanced closure properties than you would have seen in 360 or 365. We look at other equivalent models like the two-way DFA, where the head can move in either direction on the input instead of just from left to right. We look at the Myhill-Nerode theorem, which is one of the most basic results about regular languages. We looked at ambiguity of CFGs in 360 or 365. Typically, you just see some discussion of this, but you don't see proof, for example, that there exists inherently ambiguous CFLs. We do that in 462. We look at closure properties of context-free languages. We look at parsing methods, typically something like LL1 or LR0. And we look at the Chomsky hierarchy, which includes languages like the context-sensitive languages, which you typically don't cover at all in 360. DCFLs, deterministic context-free languages, and sometimes other language classes. And also 2DPDAs, which is the model of push-down automaton, where, again, you can move both directions on the input. So this is, again, offered only in the winter, so I'll be teaching it in this coming winter term. And I've changed the organization a little bit. Now we have small assignments, but we have a lot of them, so 10 of them worth 60% of the mark, and no midterm, and then there's a final worth 40%, which is a take-home final. A take-home final not usually offered in other courses, so it's a little bit unusual. It's you get the final at the end of the term, and then you have 1 week to do it. And you can use any sources except other living people. So you can use any books or material on the internet and so forth. But you can't go up to Craig Kaplan and ask him to solve it for you. Oh, I forgot.
That might be a bad idea.
I forgot. You're not living. You're a zombie. But yeah, okay. But so that's prohibited. Most people really enjoy the take-home final experience. I talked to several of them shortly after they were released from the hospital, and they you know, other than the psychological trauma, they really enjoyed it. So I hope you will too. So the textbook is this book, which I wrote, and it has a cover that was done by Craig Kaplan. So you might enjoy, at least the cover is really good. So I think that's it. And any questions about any of these courses? So I hope I will see some of you in 462 in the winter. It's a really exciting course. I have to say that sometimes in the course we have had students that solve open problems and get publications out of them. So it doesn't happen every year, but it has happened. And so I encourage you to come to 462 in the winter if you've had 360 or 365.